In Pure 1, the vectors that you do are in 2 dimensions. So you're working with an x-axis and a y-axis. So as a result, your unit vectors are i's and j's, right? Now in A2, the only difference is there's another axis. So now you're working with an x, y, and z axis. So the unit vectors are I, j, and k. I can be represented by this column notation, j is this column notation, and k is this column notation. The way you solve vectors is the exact same though. Working out the magnitude is going to be the same way. So everything that you know so far, everything you've done already with vectors, it's going to be the same. There's no difference. It's just now you have another term. You have k to be mindful of. Now, what you also need to know now are how you work with angles. So it says find the angles that the vector a equals 2i minus 3j minus k makes with each of the positive coordinate axis to 1 decimal place. Okay, there is a formula which you can use for this. If your vector is in this form, xi plus yj plus zk, and the vectors I have underlined, if you want to work out the angle with the axis, depending on which axis you're looking at, you're going to use cos theta and then that axis. So x is going to be equal to x coefficient over the magnitude of A, your total vector. So similarly, for cos theta y, it's going to be y over magnitude of A. Cos theta z, it's going to be z over the magnitude of A. So how do we work out the magnitude of A? You're going to do each of your coefficients squared, and you're going to do that under the square root. So square root of 2 squared plus minus 3 squared plus minus 1 squared, which gives root 14 in total. Now, cos theta x is going to be 2 over root 14, and now you do cos minus 1. So theta x equals 57.7. Theta y would be 143.3, and then theta z would be 105.5. That's it. Nice and easy. Okay? Cool. Let me go through this question, and then you're going to try one on your own. So, in this question, it's given you the point A, it's given you the point B, it's given you the point C. Okay, find the vectors AB, AC, BC. Cool. To work out AB, you can use the position vectors. So OB minus OA. Okay, so if I were to randomly draw from A to B, that's my... Actually, let's not do it so random. Let's do it on an axis. There. Y, X, Z. 3, 4, 8. I'm going to say somewhere here. 1 minus 2. 1 minus 2, 5 is going to be somewhere there. So this is A, that's B. and this is my origin here. Do those in red. So if I want A to B, I'm going to go from A to O, which is the same as minus OA, and then O to B. A to O plus O to B. And this is equal to minus OA. That's how I got this. So to go from O to A, my position vector, I minus 2j plus 5k minus, sorry, that was O to B, and then O to A is going to be 3i plus 4j plus 8k. There we go. So because I've got the coordinates 3, 4, 8, 1, minus 2, 5, if I want to make that a position vector, I just do that in relation to the origin. So now those coordinates become vectors. I minus 3j, sorry, minus 3i is minus 2i. Minus 2j minus 4j is minus 6j. 5k minus 8k is minus 3k. There we go. That's AB. Can you try AC for me, please? So C has the coordinate 7 minus 5, 7. So let's go 7 minus 5 up 7. So I'm going to say it's somewhere here-ish. Let's make that C. 7 minus 5. Actually, shouldn't be there, sorry. 7 is here, minus 5 is here, 7 is up there. Yeah, there we go. Something like that. This is C. Okay, so if I get rid of these red ones, and I just do it in blue, there, there, there. My triangle, therefore, I'll do in red, there, there, there. Okay, so to go from A to C, you have to go from A to O, and then you can go along OC, which is the same as minus OA plus OC. So minus 3i plus 4j plus 8k plus 7i minus 5j plus 7k, which gives 4i minus 9j minus k. Cool. Now it's BC. To go from B to C, we can go BO and then OC. So OC minus OB. That would simplify to 6i minus 3j plus 2k after doing the same process as the other two. That's part A done. Part B. Hence find the lengths of the sides of triangle ABC. Okay, so you need to work out, or we would need to work out, the magnitude of AB and BC and AC. So you do the square root of each coefficient squared. This should give root 49, which is 7. This would give root 98, which is 7 root 2. This would give root 49, which is, again, 7. Given that the angle ABC is 90 degrees, find the size of angle BAC. This one is pretty straightforward because you know that two of the lengths are the same. What triangle has two lengths which are the same? An isosceles, right? So drawing an isosceles is going to be something like this. 7, 7, 7 root 2. They've said that this is a right angle, and angles in a triangle need to add up to 180. If that one's 90, the other two need to also be 90 together. So each one here and here is 45. There you go, done. Nice and easy. Okay, question 17. I want you to try that on your own, please. Okay, they've given you the triangle, they've told you PQ, they've told you QR, and the angle PQR. Okay, I would start by working out the magnitude of PQ and QR. So PQ is root 14, QR is root 29. Because you have PQ and QR, you can also work out PR. To work out PR, you would do PQ plus QR. So 3i plus minus 2i is just I. Minus j plus 4j is 3j. 2k plus 3k is 5k. So the magnitude of PR would be the square root of 1 squared plus 3 squared plus 5 squared. So root 35. Okay, so PQ, root 14, QR, root 29, PR, root 35. Let's make that 3 a bit better. And then PQR here is 78.5 degrees. Or, sorry, you're trying to show that that is 78.5 degrees. Let's use theta. What can you use to work this out? The cosine rule. So a squared equals b squared plus c squared minus 2bc cos a, where a is our q. So root 35 squared is 35. Root 14 squared is 14. Root 29 squared is 29. Minus 2 times root 14 times root 29 cos theta. And then it's just a matter of solving that. So after solving that, after doing cos minus 1, you should have 78.5 degrees. And that is your answer. There you go. That is how you work with 3D vectors.